I have a question.
Yeah.
Could you make us able to see which questions on the quizzes we answered wrong?
Yes, I can do it. So I tried to do it today because I have to manually change some settings in quiz. Okay. So prompt me if it it will not be done today. Okay. Yeah, today we have quiz. It will be at the end of the second lecture. So so about yeah, so it will be 10 minutes before the end of the second lecture. Okay. Okay. So today I'd like to tell you something about structures, and then combine structures and pointers. So I will be talking about dynamic data structures. But let's start from the structures. So maybe it will be easier to understand structures on simple example. So look, let's assume that I'd like to represent information about a certain, maybe about one student. Yeah, so so I need its name, let's say 30 characters, maybe about age, maybe gender, okay, there can be also, for example, something which is called album or student ID. Why we didn't put number or on car gender? So I expect that gender will be man, for example, or woman. Yeah. So there will be characters. Okay, so hope everyone can see my desktop. Yeah. Okay. Of course, I record this session so you can watch it also later on. So look, if I want to handle with this set of data, I need to, for example, scene name, then scene. Okay, I can do it in single line. So running this program, I expect that user enter, or maybe it should be first, maybe first name and last name. So it will be easier to acquire these elements with cin, because cin takes only a single word, so all characters to end of line or to first space. So I expect something like this. So the user should enter Piotr, Kaczmarek, age 40, age, gender man, okay, student ID, something like this. Okay, so this is the pattern I have to enter. Yeah, but look, if I want to represent more students, I have certain problem, because I have to duplicate all of these variables. So, okay, I can create something like this. No? And again, I need the function which works like that. So I have to run it again. Of course, you can see that this section is repeated, but for different parameters. So to not duplicate this section, I can simply create a function. So let's say void get data, and here I can take these elements and write car pointer first name, car pointer last name, int reference age, car reference gender, and int reference student ID. And then inside this function, I can write something like this. And then to call this function, I can write get data. First name, last name, age, gender, student ID. Okay. I can repeat this. So call this this function again for other variables. No. But look, okay, if I'd like to add third subject, I have to duplicate these variables, and I have to duplicate or call get data again. So this way is inefficient. So what shall we do? Using your current knowledge, we can create arrays. So I can create array of first names. So let's say 10. I can create array of last names, also 10 elements of ages, 10 elements of genders, and of students' IDs. So, okay, because this is array of characters, here we have two-dimensional array. So we have we are able to store 10 strings composed at maximum of 20 elements. Okay, so if I have array to get all of these students, it is enough to get first name index I, last name index I, age index I, gender index I, student ID index I. So in every iteration, I refer to ith element in this arrays. Okay. So look, here is the solution how we can refactorize our code to handle more than a single subject. But still, regarding program logic, this code is inconsistent because I have first name, so I have separate array for first names, for last names. So, but in logical point of view, the first name, last name, age, gender, and student ID belongs to a single individual. So they should be grouped together. So what is the solution which should be applied here? The solution is to use a structure. So what is the structure? The structure struct, okay, this structure is a new type. So I can call this type, for example, student. So it's a new type which can be composed of different elements. So I can compose this type of the, for example, arrays. So I can represent character, text. I can represent age. I can represent student ID. Of course, here I can add more fields regarding nomenclature. So a single entry here is called structure field or structure attribute. So here I have 4 attributes. Of course, I can insert more attributes like address, nodes, or faculty, etc. So you can see that the structure size can be much higher. So if I want to use, oops, okay. So how to use structure? If I'd like to declare a single student, I can write student. Student. So this is single variable, and inside this variable I have all of this information. So how to get or write this data from and into this element? So when I write student, I can select, so this is that operator, it is called selector. So I can select the field I want to use. So for example, age. So now I have variable student and its property or field age. And now I can, for example, write here. When I'd like to get access to, for example, first name, I write cn student first name. So look, still to read or write information from this structure, I have to address particular fields. But now all these fields belongs to particular students, so they are somehow grouped together. In case of arrays, there is a separate array for names, separate array for fields, so they are not so strictly grouped. So how to write get data, which let us to handle with the structure. So the easiest way is to pass the student. Oops. Okay, I should do it before. So after the structure is declared, so I have student, the reference student, and now I can get access to the student first name, student last name, student age, student gender, and student ID. Okay. What's okay here? I don't have gender. So to call this function, get data. So because this argument is passed by reference, everything you do inside this function will affect the original argument. So now look, if I want to represent more than single student, I can create an array of students. So now I have to take the ith student from this array. By the way, okay, here I have a single variable. By the way, how to get access to, so I'd like to modify without function. Yeah? I'd like to modify all fields which are called age. So I'd like to assign, let's say 10 to every attribute property which is called age. So what should be here? Do you have any idea what should be printed here to change or to initialize all fields age, so ages of all students to be equal to 10? Yeah, student I.age. So first I select the ith element of the okay, here I should have students. Okay, so I should select ith elements from array of students and then get access to age. Okay, so I think it should be quite clear how to, you know, create structures and how to handle with structures the easiest easiest form. No? So now I'd like to tell you something about, so the structures are the user-defined type. This type is defined by users. So there are no operators like seen. Oops. So I can't write, for example, cn students ith. Yeah? So I can do it. Okay, I can do it provided that I create or overload the operator, the string operator, but now it doesn't work. There is an error because cn at default operates only on embedded types like int, float, string, array of characters, and so on. But of course, I can get data when I get access to particular field, which is user-defined type, embedded type. Okay. So now I'd like to tell you something about arguments passing. So let's assume that I'd like to write function print student. Oh, maybe before, let's assume that when I take all information from the user input, I'd like to print all these things. So I'd like to print the list of these students. And now, look, to do it, so to write the print function, which is compatible with this use case, I can do two things. So first way is to pass argument by value. So in this case, I can do the same or something similar to get data, but now I'd like to see out it. Of course, to make it more clear, I should insert separators or comments here. But let's say that separators spaces are good enough. Okay, but what is the problem with this call? So, okay, that works. So let's say that I have only 3 elements here. So I should write first, last, age, gender, and ID. Okay. So you can see that this data were first acquired from input, and then they will be printed on the output. So this example works fine, but what is wrong or improper with the print function? So what about the argument type? So look, this argument back. Okay, so look. What's wrong with the print? The problem is that if you look at this structure and we try to estimate what is the size of a single element in memory, we can roughly count that there is 20 bytes for first name, 20 for last name, so we have 30, 4 bytes for age, 44, 45 for gender, and 49, so 49 bytes for the whole structure. So look, if I pass argument by value, this argument has to be copied. So new memory has to be allocated, and all elements from the source element has to be copied to the argument. So regarding function call performance and stack usage, it is inefficient. Therefore, when we have the elements or arguments which are larger than let's say int or float, we always should pass this argument as a reference. Because having reference, the student is the reference to ith element of this array. But when we pass argument by reference, we tell the user that it is because I'd like to modify those elements inside the function. So I'd like to return a result outside. So to indicate that we do it only because we want to achieve higher performance, we have to declare this argument as const reference. So remember that all elements, if you pass the argument like this, for entering data, it should be passed by reference or by pointer. We'll be talking about pointer in a moment. But if you pass arguments to read, we should pass it as a const reference. So now you can see that it works as well. So there are no error. And the performance of this kind of call is higher. Yeah? Okay. So now I'd like to tell you something about passing arguments by pointer. So let's assume that I'd like to define, oops. I'd like to define a pointer to student. And I can allocate here a new memory. Yeah? So remember that this memory should be released before we leave the scope. So somewhere I should use delete ptr. Okay. So when I have a pointer to get access to particular property, I have to write pointer and look to I should the reference from this address, and then I can write age. So this is, compatible or in analogy to standard pointer use cases. But for structure, I can, if I have pointer, I can do the same, and I change the selector symbol. So instead of using that, I use arrow. Yeah? So here, if you use arrows is, yeah, these two notations are equivalent. But this notation is much more popular. So, so for structures, later for classes, if you have pointer to structure element or pointer to class object, we should use the selector, which is arrow. Yeah? For other elements like automatic variables, we should use pointer. Yeah? So like this. Yeah? Okay. So look, I can write the same function, get data. Let's say get data. Okay, get data. I can use it in a form where not reference, but pointer is passed. So in this case, I have to write student first name, student last name, student age, student gender, and student ID. So this is the only change you have to make to operate on pointers or on standard automatic types. So to call this function, I have to pass the address of ith element. So I can write it like this. So here I have two overload functions, get data. This one is called when the address is passed. This one will be, oh, sorry. This one will be called when address is passed, and this one will be called where standard variable is passed. So when I get the address of the ith element, this function will be automatically called. Okay. So try to remember how to get access to properties when get data, when the standard variable is passed, and when the pointer to the variable is passed. Okay. Yeah. Sometimes when you analyze the pure C programs, the structure definition looks different, a little bit different. There is also a keyword structure, but before there is a keyword type def, and the structure name is at the end. Here you can see that after the curly braces, this here, there is always a semicolon. If there are no semicolon, you can see that, okay, there's a problem, yeah? Semicolon expected. Why the semicolon is here? So, sometimes when we want to create a structure, we use only, for a single purpose, we can define structure on this way. So we can skip the type name, but here I can so look, here I can specify the variable name. So this creates a variable point of which is the structure consisted of two elements, but the structure name is undefined. So now I can write point x, for example, equal 5. So I can use this variable as standard structure, but I can't create the second variable of this type because the type is not defined. Okay, I can of course create both a variable and type. So now this is variable which type is point. So the variable was defined together with structure definition. But here I can write point P2 and now P2 x. So here between the end of this closed brace, I can insert the variable name. And the variable name is terminated with semicolon. But if I don't declare variable here, still the semicolon should be inserted. Yeah, Mr. Korzeniowski. Yeah, this is usually this kind of definition is used for a single use. Yeah, so sometimes it is used, but usually we try to declare structures. So as a type, and we use this type in several places. Okay. So here you have some examples which are similar to those I presented you before. So, okay, arrays. Here, pointers to structures, passing arguments. Okay, so now I'd like to tell you about memory allocation. So I showed you how to allocate memory for a single variable, but I can also allocate memory for array of students. So I can allocate as many elements as I need. But if I allocate memory for array of students, I have to release it. Okay, so look, if we define the array of students dynamically, the size of this array is, let's say, unlimited. Yeah, so potentially we can, build a database of students of arbitrary size, so there are no restriction what should be the number of students, so whether it should be 100 or 1,000 people. So, but there are some drawbacks of this representation. So creating array of students let us to store inhomogeneous elements. So together I can represent character strings and other elements. So I have the elements which are not homogeneous, but there are some problems. So look. So let's assume that I'd like to okay. So let's assume that I have array of students. So here I have n elements. And every element of this array has, let's say, m, or maybe not, 39 bytes, as this structural element we created before. So when I like to insert a new element here, what shall I do? So I'd like to add a new element at the end. Do you have any ideas? Yeah. So look, to do it, I have to allocate memory for bigger array, and then all elements should be copied here. Okay, and of course, this new one should be also copied. Yeah. So assuming that I have one million of elements, and I'd like to add one, you can see that 49 million or megabytes should be copied to insert a single element of size 49 bytes. So this process will take, or can take potentially, longer time than it should be expected based on the size of particular element. So the process, the time of this process is determined by the size of current set. So this is the first problem I can show you, which is related to representing data in arrays. The second case. So in the second case, let's assume that I have, again, array of n elements. And now I want to delete this element. So I'd like to remove it. It is impossible to remove the middle element from the memory which was allocated as homogeneous block. But I can do it by writing or copying all elements or further elements one position up, and assuming that somewhere I store the number of elements, so the number will be n-1. So it's enough. I don't need to deallocate memory and copy all elements to new memory. Of course, but I have to copy all elements one position up. So the worst case, if I decide to delete the first element, I have to perform n-1 times 49 bytes. So I have to copy these elements. Yeah. So in case of 1 million elements, it is again 49 megabytes of data. I hope you understand that 49 bytes, it's, you know, regarding the size of information we can represent for particular students, it's only you know, this structure can be definitely larger. Yeah, so this process depends on the number of elements and the structure size. So this is the second case. What else? Oops. Okay, the third case is related to elements swapping. So I showed you how to sort elements in array, and you should remember that the sorting elements consist of a number of swapping operations. So when I like to sort elements, I have to perform or to swap two elements many times. For bubble sort, the number of swaps is proportional to n squared. So it is proportional to squared size of the array. So look, if I'd like to swap these elements, I have to perform 3 copy operations. So I have to copy for a single swap. I have to copy 3 times 49 bytes or more. Yeah, if this structure is bigger. Yeah, so here it is okay. Let's say 150 bytes for a simple calculation. So if I have 1,000 elements in my database, here I have 1 million of potential swaps times 150 bytes. It gives me 150 megabytes to swap. So many, elements or data has to be copied. So it seems to be quite inefficient to perform so many operations. Of course, if we use, let's say, quicksort or other algorithm, the number of swaps will be smaller, but still, the execution time depends on the size of particular element. So it may strongly influence on this. Okay, so you should be conscious that there are some drawbacks of arrays applications, but of course there are some benefits also. So what are the benefits of arrays? So first, it is super simple to handle. So if I need array of size n, it is enough to write new student index n. So this is the first benefit. The second benefit is that because the array stores data in continuous space, so having the pointer to first element, so pointer, I can simply calculate the address of any further element. So it's enough to calculate pointer plus k. So look, having the beginning of this structure in a single operation, I can get access to any element here. So therefore, I can, for example, use a binary search. Because in binary search, I have the pointer to the first element, but I like to read the middle one. So this is a very important property of arrays. It is called random access. So I can randomly access to any field. Today I will be talking about more complex data structures, and you will see that for this data structures like list, like trees, okay, the drawbacks of arrays doesn't exist, but it is impossible to get address of any elements in a single calculation. So remember that the arrays, because despite they have some drawbacks, they are the most commonly used dynamic data structures. So they Mr. Dennis, I don't understand your question. So
I was asking if we can access to a specific area other than accessing with random.
Yeah, okay, we can, but we have to know where particular element is located.
I think he understood
you
it
will see
as
that if
random
elements are located, so they are not in continuous area, so they are, somewhere in memory, having the address to first one, I can't infer the address of other elements, because usually it will be like that the first element knows where is the next one, the next element knows where is the second, and so on. So to get, let's say, this element, I have to look at the first, the second, the third, and then I can infer the address of the fifth or fourth element. Yeah. So random access means that having a single address, I can calculate something. So in single, let's say, processor cycle, and I know where is the next element. Okay, but now I'd like to pay your attention for this property, and then I will tell you how it is implemented for other structures. Okay, so now we go to the other dynamic data structure. So dynamically allocated array is one of the dynamic data structures, but there are also others, other structures. Here you have a list. So there is a stack, queue, list, tree, and graph. So these are the five most commonly used or basic dynamic data structures we can implement. Of course, they are used depending on application. So for some applications, we use stack, queue, list, tree, and graphs. So first, I'd like to start from stack. I showed you, talking about memory organization, I showed you that there are two elements. So in memory, we have something which is called stack and something which is called heap. So when function is called, all its data are put on a stack. So then when the next function inside this function is called, so for example, when we use recursive call, so this function put this data on the stack. So the only thing we know about stack is the top of the stack. So it is called a stack pointer. So here the same, we have stack pointer. And then when I'd like to remove particular element from the stack, I have to first remove the element which is on the top. So all elements before. So I can't take this element when other elements are above. So the same in function. So when I called function recursively, first the most current function has to be finished, and then I can get access to the parent function and so on and so on. Okay, so it is impossible to get access to the most bottom element without removing the previous or the later elements. The second dynamic data structure is called FIFO. So it is queue. And queue works like this. The elements are added to queue from the one entry or one side of the queue, but they can be read or taken from queue from the other or opposite side. So if I'd like to take this element, I have to read this one. So FIFO is commonly used structure or organization for storage process. For example, in for example, in store, if we have shelf, when a product is delivered, it is put from the one side of this shelf, and then when there is an order or the customer wants to take this product, it takes this product from the opposite side of the shelf. What do you think? What is the benefit of this organization for storage process?
Stuff on the back doesn't rot.
One more time, please.
When the shelf is supplied like that, the products that customer buys have are closest to the best before date.
Yeah.
So
yeah.
if it was the other way around, the stuff in the back would rot.
Yeah. So we can manage the, take the product. So the products, the oldest products are taken first. So FIFO means first input, first output. Yeah. So the first element which was inserted will be the first element which will be outputted. FIFO is also used in computers to organize the process of reading data from console. So now I'd like to show you a short example. So look, let's assume that I'd like to, we have two variables. And I'd like to, 10 times, I'd like to take a value from the user input, and I'd like to see out it on the output. So here we have very simple program, and look, when I press 2, okay, 2 is printed, 3, okay, 3 is printed. So here you have the iteration value, so I value, and here you have the value of A, so the value which I entered. So look, now I press D. So look, what happened? Are we able to interpret this effect? So definitely D is not the character which was expected. Yeah? But why this effect is observed? and more. Yeah, it started from 0 because I is 0. I don't understand. Okay, so initially I is 0, so in first iteration A is 0 and I is 0 and A is the same what I inserted. No? Okay. Why it started at 2? Yeah, because I is the value of I changes from 0 to 10 to 9. So let's run it again. So 4, 0, 4, 2, 1, 2, 5, 2, 5. Yeah, so here you have the value of variable I. And then when I press F, you can see that this loop is executed, but it doesn't stop on CNA. Yeah? Because I expect, yeah. Okay, Mr. Claps, that's true, but I'd like to tell you what is the problem here. Why this loop is executed, you know, infinitely, in fact, yeah, because if we have, for example, 100, it will be executed 100 times. So what's wrong here? Okay, okay. So I'd like to explain the reason for that. Okay. So look. The keyboard buffer is organized in FIFO way. So if we press key, the key is inserted to FIFO. So for example, I press 4 space 2 space. Yeah, so this is the what I entered. So I entered 4 space 2 space. So they are put it to or inserted to this buffer in the order in which they were printed. And here I have D. So then when I press cin, when I call cin, it takes and cin, let's say A, it expects that the values in buffer should be digits. So it takes the first element, verify whether it is a digit, and if yes, it assign it to A. If there are more digits, okay, A will be, for example, if there is 114, yeah. So the first digit will be 1, the second 4, and there will be space. So if it finds the character which is not a digit, it stops reading. So after first iteration, the A will be equal 14. then there is a space. So space is treated by default is treated as separator, so it is ignored. But the process of reading stops here. So now in my FIFO, there is 2. So again, when I run my loop, I get 2a equal to 2. Okay, so when I try to read the value again, so in the third iteration, there will be d. So d will not be recognized as a valid digit. So in this case, d will not be taken or will not be read from the buffer. So it will be there until I. Okay, so even there are some other values here. It is impossible to read them unless the d is there. And when I try to see in a and there is a d, nothing is taken from buffer. So a is equal to 0 and nothing will be read. So every time I try to, so again, where there is a d at the end of buffer, so in fourth iteration, so nothing is read. In third iteration still, there is a d. Yeah? So therefore, this process is executed infinitely. So what should be done? Okay. First, if something was wrong with my input, so the conversion was failed, I can detect it, seen, fail. So I can detect whether it was failed. So I can make it again, cin, clear. So I can recover this state. So good state again. But remember that it changed only, okay, it tells me it was failed, but okay, I said, oh, okay, it is fine now. But still, this D so in my buffer, D is still there. So I can see out. Conversion failed. What can I do? I can, for example, create a car word and I can try to read it. So cin word. So let's try to run it. So 2, 4, 6, and now I press D or DE, whatever. So conversion failed. Yeah. And now it works fine. But if I don't read these elements, look, 2, 4, 5, D, conversion failed. It was set as a true, but in my keyboard buffer, there always is the character D. So unless it will be read before, nothing will be converted to int. Okay. The more popular way to handle with this problem is to write std ignore cin, sorry, cin ignore, and it let us to ignore or to wipe out all elements from buffer. So it clears the buffer, and now the buffer is empty after cin ignore. So, but both ways are proper. So we can read in proper element. So I can read this D, for example, or I can ignore all further elements in my buffer. So running it again. 2, 5, 6, D. Okay, conversion failed. The buffer was ignored, so it was cleared. 4, 6, 5. So this is also FIFO structure. So you should know how FIFO works and where it is used. Okay, Mr. Janiszewski, good question. As far as I know, it should ignore all elements until the end of line, but we can CPP reference. We can verify it because ignore has a default argument, which okay, I have to check. Okay, input stream ignore. So okay, so it ignores by default. It ignores only a single character. We can specify more characters, and no more than the delimiter. So I can use ignore, for example, to ignore all elements until end of line. So here you have the full form of ignore. In this example, so without arguments, it ignores only a single character. So if there will be more than one character, it doesn't work. But you can specify something like this. So the maximum size of the buffer, okay, and the character, which is delimiter, so it should stop the ignoring process. If not, so by default, the end of array is the character which makes the ignore stop. Okay, so I think it's time for half an hour for break. Yeah, so we will meet in half of hour, and we will continue.